Okay, so today we are going to be looking at Learning Target 1 from Unit 8, which is I can calculate the volume of a cylinder, cone, and sphere. And we're going to be looking at the volume of a sphere and also adding in how we can calculate the volume of a hemisphere, which is very similar to a sphere. So a sphere has a completely different volume formula than the two that we've worked with so far. And that formula is that volume equals 4/3 times pi times radius cubed. Okay, so that's a little different than our area of the base times height and such. There really isn't a height that we would use in a sphere, so we're using the radius cubed. If we were working with hemispheres, a hemisphere is half the size of a sphere. So if you were to take all of the values that you have, calculate it using the sphere formula, and then divide by 2, that would give you the volume of a hemisphere. Or we also have the formula for a hemisphere is 2/3 pi r cubed. So you could definitely use that as well. It's just make sure that you're very attentive to which formula you're using and for which shape, so that you're not using the hemisphere formula for a sphere or mixing up those fractions. So looking at example 1, it says find the volume of a sphere round to the nearest hundredth. Okay, so I know that my volume is going to be 4/3 times pi times radius cubed. Okay, again, that's an area that a lot of people tend to make mistakes after working with cylinders and cones, is they want to square that radius. Not with spheres or hemispheres. We need to make sure that we are cubing it. Okay, and looking at my diagram here, my picture, I can see that my radius is 6. So volume equals 4/3 times pi times 6 cubed. Okay, and 6 cubed, remember if you need to do 6 cubed, you can either do 6 times 6 times 6, or if you're looking at your calculator, you can type in 6 and then this up caret button right here, and then 3. So it would be 6 up caret 3, and that would give you your answer of 216. So we have 4/3 times pi times 216. Okay. And to multiply by 4/3, what you could do is you could do 216 times 4 and then divide by 3, and so that would give you 288. So you have 288 times pi. So if I said keep your answer in terms of pi, you could stop there. However, I didn't ask you to do that. I asked you to round to the nearest hundredth, so you're going to take 288, multiply it by the pi button, and you get 904.78 millimeters cubed for your volume of this sphere. In example 2, it says find the volume of the hemisphere. Hemisphere, again, remember, is going to be half of a sphere, so round your answer to the nearest hundredth. So I'm going to use my formula for a hemisphere, which is 2/3 pi radius cubed. I know that my radius is 5, so times 5 cubed, and 5 times 5 times 5, hopefully we remember from our previous unit, is 125. And then we can multiply by 2 and divide by 3, or we could just multiply by 2/3. We get 83.33333 repeating, so 83 1/3 times pi. And again, we're not keeping it in terms of pi, so without clearing my calculator, I'm just going to press times pi, and so I get 261.799, so that would round to 0.8 or 0.80 if you wanted to keep it with the hundredths places. So my volume is 261 80 centimeters cubed. In example 3, A spherical stone in the courtyard of a national museum of Costa Rica has a diameter, woohoo, be careful with the diameters, diameter of about 8 feet. Find the volume of a spherical stone. Round your answer to the nearest tenth. Okay, so this problem has a few curveballs in it that are a little different than what we've been doing, so we want to make sure that we're paying attention. So we see that it's a spherical stone, so we're going to be using our sphere formula, which is 4/3 pi times radius cubed. And you'll notice in the problem that it gave us the diameter. So in order to get the radius, I have to cut that diameter in half. So that would be 4/3. And 4 to the third power we know is 64. So 4/3 times pi times 64. So 64 times 4 divided by 3, it gives us 85 1/3 times pi. And so if I multiply by pi, that gives me 268 8/8 feet cubed. So that is our volume for this spherical stone at the National Museum of Costa Rica. Oh, but it says to the nearest tenth. Goodness gracious, pay attention, Mrs. Malloy. 268 1/10 feet cubed. So again, following directions, making sure that we're not getting tricked by the things that it's asking us. I'm pretty sure I will not do that to you on an assessment, but sometimes mistakes happen and things fall through the cracks, just as this question did. So make sure you're paying attention. All right, finding the missing values. So again, we're going to be using our pi button for pi. A regular basketball used in men's basketball has a volume of 7,238 centimeters cubed. What is the radius of the basketball? Round to the nearest hole. All right, so again, we're going to start with our volume. We know a basketball is not a hemisphere. It would not bounce very well if it was. So it is a sphere times pi, radius cubed. My volume that I'm told is 7,238 equals 4/3 pi times radius cubed. So I need to divide both sides by 4/3 pi, divide by 4/3 pi. So in your calculator, I might type 7,238 divided by parenthesis 4 divided by 3, close parenthesis, pi. And we get the answer for our radius cubed. Radius cubed equals 1,727.94521, and so on. So without clearing my calculator, I'm going to take the cubic root. And so to do that on your calculator, if you have the scientific calculator here, do not clear your calculator. You're going to type in 3 second, and then the up caret. You'll notice that above there is the radical with the x where our 3 has been. And so you'll have on your calculator, it'll read like that, and then you're going to press second again, and then that negative symbol for answer. And you'll have A and S, and then press enter. And we get the not rounded answer of R equals 11.9998, but our answer or question said to round to the nearest hole, so the radius is approximately 12 centimeters for a basketball, a regulation basketball used in men's basketball. Okay, so your homework is on deltamath.com. Again, you have 5 problems to complete. You have 2 attempts to get it right before it marks you off, and you'll have to do more to make up for the ones you're getting wrong. So make sure you're taking your time. You're using the pi button. and you're rounding properly. If you have any questions, come by during office hours, 12:30 to 1:30, or send me an email. Okay, good luck. Talk to you later. Bye.